In the previous lecture, we have discussed about priority scheduling and we have seen how it works. So in this lecture, we'll be discussing a solved problem on priority scheduling. And this question was also asked in GATE CS 2017. Alright, so let's see what is the question and let's see how we can solve it. So here is the problem. Consider the set of processes with arrival time given in milliseconds, CPU burst time given in milliseconds, and priority where 0 is the highest priority shown below. None of the processes have I/O burst time. The average waiting time in milliseconds of all the processes using preemptive priority scheduling algorithm is blank. Alright, first of all, let's try to understand what this question is trying to ask. So here it says that we are given 5 processes with process IDs P1 to P5 and their arrival times given in milliseconds, which is shown here, and their burst times also given in milliseconds, which is shown here. And then we are having the priority of each of these processes shown in this last column. And then 0 is the highest priority. So if you see 0, this is the highest priority, and the next highest priority will be 1, then 2, and 3, and 4. So we are given this much of information. And then also it is said that none of the processes have I/O burst time. So what they mean by this is that here we are given the burst time. So burst time is the time that a process spends execution in the CPU. And I/O burst time is the time that the process spends for input-output operations. So here it says that it does not have any I/O burst time. So we just need to consider only the CPU burst times which are given here. Alright, so given these informations, we are to calculate the average waiting time in milliseconds of all the processes given above using preemptive priority scheduling algorithm. So we need to assume that the CPU is following a preemptive priority scheduling algorithm. And if it is following a preemptive priority scheduling algorithm, then what will be the average waiting time for this set of 5 processes? So that is what we are asked. And we are given 4 options: A29, B30, C31, and D32. So these options are very similar to each other. So if you are trying to guess, then you may have a hard luck. So let us see how we can solve this in the correct way and find out what is the answer. So coming to the solution, I have just copied down that same table here, and we are going to first form the Gantt chart for this. So the most important thing in solving this kind of problems related to scheduling is forming the Gantt chart. So if you are able to form the Gantt chart correctly, you can easily solve any problems related to this. So first of all, let's see how we can form the Gantt chart. And keep in mind that this is a priority preemptive scheduling. It is preemptive. So when a process of higher priority arrives, then if the priority of that process is higher than that of the currently executing process, then the currently executing process can be preempted or the CPU can be taken away from it. So keep this in mind. Alright, so let's see how the Gantt chart for this can be formed. So here is a Gantt chart for this set of processes if they are following a preemptive priority scheduling. So if we look at this table, let's see which is the first process to arrive. So we see that P1 arrives at time 0. So P1 is the first process to arrive. And what is the priority of P1? It is 2. Since P1 is the first process to arrive and since there were no other processes at that time, so P1 will be the first one to get the CPU in this case. So P1 gets the CPU and begins its execution. And how long will P1 execute? It has to execute for 11 milliseconds. That is the burst time of P1. So did P1 execute for 11 milliseconds? No. Let's see why. That is because the next arrival time that we have is 2. At the second millisecond, P4 has arrived. So P4 arrives at 2 milliseconds, and let's see what is the priority of P4. The priority of P4 is 1. So is the priority of P4 higher than that of the currently executing process, which was P1? Let's see. P1's priority was 2 and P4's priority is 1. So always keep in mind that the lesser the value, the higher the priority. So here P4 is having the lesser value, which is 1. That means the priority of P4 is higher than that of P1. So what will happen? P1 will be preempted and P4 will get the CPU. So the CPU is taken away from P1 and P4 gets the CPU at 2 milliseconds. So how long did P1 execute? P1 executed just for 2 milliseconds. And the burst time of P1 was 11 milliseconds. So if we subtract 2 from 11, P1 has a remaining of 9 milliseconds to execute. So P1 will still have to execute for 9 milliseconds the next time it will get the CPU. So right now P4 got the CPU and it's beginning its execution. So let's see, P4 continues its execution and let's see what happens. So what is the next arrival time that we have after P4? It is P2, which arrives at 5 milliseconds. So P2 arrives at 5 milliseconds and let's check the priority of P2. It is 0. So 0 is the highest priority that we have. So the priority of P2 is higher than that of P4, which was currently executing. So what will happen? P4 will also be preempted and P2 will get the CPU. So the CPU is taken away from P4 and P2 gets the CPU for its execution. So how long did P4 execute? P4 executed from 2 to 5 milliseconds. So that means it completed 3 milliseconds of its execution. And what is the total burst time of P4? It is actually 10 milliseconds. So from the 10 milliseconds, if we subtract this 3 milliseconds which was already executed, we have a remaining of 7 milliseconds for P4. So P4 will again have to execute for 7 milliseconds later when it gets the CPU. Alright, so let's see. So P2 now got the CPU and it's continuing its execution. Now if you look at this table, after P2, let's see what are the other processes that arrives. So after P2, which arrived at 5 milliseconds, the next process to arrive is P5, which arrived at 9 milliseconds. And after that, even P3 arrived at the 12th millisecond. So this 9 and this 12 all fall under this 5 to 33. That means during the execution time of P2, these two processes P5 and P3 arrived. But did they get the CPU? No. Why did they not get the CPU? Because the priority of P5 is actually 4, which is less than that of P2. And then the priority of P3 is also 3, which is also less than that of P2. So P2, as I told you, has 0 priority, which means the highest priority. So no processes will preempt P2 because it is of the highest priority. So P2 will actually execute for its total burst time of 28 milliseconds. So from the 5th millisecond when P2 got the CPU up to 33 milliseconds, 5 plus 28 is 33. So up to the 33 milliseconds, P2 uses the CPU for its execution. Alright, now at 33 milliseconds, P2 will release the CPU and let's see what are the next processes that we have and who is going to get the CPU next. Now if we look here, let's just cross out P2 because P2 has completed its execution. Now in the remaining processes, which is the process having the highest priority? So we have P1 with a burst time of 9, P3 with a burst time of 2, and P4 with a burst time of 7, and P5 with a burst time of 16. Now the arrival times doesn't matter because they have all arrived and they are all waiting in the ready queue. So among these 4 processes that are present in the ready queue, the process with the highest priority will be the next to get the CPU. So let's see. Here we have P1 with a priority of 2, then P3 with priority of 3, P4 with priority of 1, and P5 with priority of 4. So which is the highest priority? We have 2, 3, 1, 4. So 1 is the highest priority that we have among these 4. So P4 will be the one to get the CPU now. So P4 gets the CPU and it is continuing its execution. So how long will P4 execute? P4 has to execute for 7 milliseconds because it has already executed 3 milliseconds before and 7 was the remaining time it has. So it will execute for 7 milliseconds. So P4 continues its execution from 33 plus 7, which is up to the 40th millisecond. Now P4 also completes its execution. So let's just cross it out. Now in the remaining processes that we have, which is P1, P3 and P5, who is having the highest priority? P1 is 2, then P3 is 3 and P5 is 4. So among 2, 3 and 4, the highest priority is of P1, which is 2. So P1 will be the next one to get the CPU. So P1 gets the CPU at the 40th millisecond when P4 releases the CPU. And how long will P1 execute? P1 will execute for 9 milliseconds. So 40 plus 9 is 49. So up to the 49th millisecond, P1 executes. And after that, let's see what are the processes that we have now. So P1 also finishes. Then the only remaining 2 processes that we have are P3 and P5. So among P3 and P5, which is the highest priority? P3's priority is 3 and P5's priority is 4. So the higher priority is that of P3, which is 3. So P3 will now get the CPU and it will execute for how long? P3 will execute only for 2 milliseconds. That is the burst time of P3. So from 49 up to 51, P3 executes and completes its execution. Now the only remaining process is P5. So P5 will finally get the CPU when P3 releases it at the 51st millisecond. So P5 gets the CPU, and how long will it execute? It will execute for 16 milliseconds. So P5 executes from 51 plus 16, that is up to 67 milliseconds. So P5 execute up to the 65 millisecond, and at this point all the processes have completed their execution. So this is how we form the Gantt chart for a set of processes that follow a preemptive priority scheduling. So we saw that whenever a process of higher priority arrives, if the executing process is of lower priority than the one that has arrived, then the process having the higher priority is given the CPU, and the process that was executing currently was preempted. So that was a simple rule that we followed, and keeping that in mind, we have formed this Gantt chart. Now if we have formed this Gantt chart, now the rest of the things becomes very easy. Now we have to calculate the average waiting time. So that is what our question was. So how do we calculate the waiting time for a set of processes that we have? So here is how we do it. Waiting time is equal to total waiting time minus number of milliseconds the process executed before minus the arrival time. So using this formula, let's calculate the waiting time for processes P1 to P5 and then see the average waiting time. So the waiting time for process P1 will be the total waiting time of P1. What is the total waiting time for P1? So to see the total waiting time, what you have to do is you have to look at the Gantt chart and see where did P1 occur the latest. So P1 occurred latest over here. This was the last occurrence of P1. So what is the waiting time for P1 during its last occurrence? It was 40. It got the CPU at the 40th millisecond. So that is the total waiting time of a particular process. So for P1 it is 40 minus the number of milliseconds the process executed before. So before executing here, did P1 execute any time before? And if yes, how long did it execute? So if you see in this Gantt chart, P1 executed even here. So, and how long did it execute? For 2 milliseconds. So minus 2 and minus the arrival time. For that you have to look at this table. So the arrival time of P1 was 0. So we have 40 minus 2 minus 0, which gives us 38 milliseconds. So that is the waiting time for P1. So similarly for P2, the waiting time is the total waiting time of P2. So where is P2? The last occurrence of P2 is here. P2 actually occurred only one time. So P2's total waiting time was 5 milliseconds minus a number of milliseconds it executed before. So we see that P2 did not execute before. So it is 0. And then the arrival time of P2. What is the arrival time of P2? It is 5. So 5 minus 0 minus 5, which is 0 milliseconds. So we see that in this table, P2 arrived at the 5th millisecond, and since it was of the highest priority among this set of processes, it was immediately given the CPU when it arrived, and it did not have to wait, and it was not preempted by any other processes because it is of the highest priority. So that is why the waiting time of P2 is 0. And what about P3? Let's see the total waiting time of P3. So the last occurrence of P3 is over here, and the total waiting time is 49 milliseconds. 49. And did P3 execute any time before? No. So the number of milliseconds the process executed earlier was 0. And then the arrival time of P3. For that we see this table and see it is 12. So 49 minus 0 minus 12 is 37 milliseconds. And similarly for P4, what is the total waiting time? P4 was here and also here. So the last occurrence of P4 is this one. So how long did it wait? 33 milliseconds minus the number of milliseconds the process executed before. So we see that P4 executed for some time even before this, that is here. And how much is it? It was for 3 milliseconds, 2 to 5, 3 milliseconds. So minus 3 minus the arrival time of P4. What is the arrival time? It is 2. So 33 minus 3 minus 2 is 28 milliseconds. And then the waiting time for P5 finally, how much is it? We see that P5 was the last one to get the CPU, and it got at the 51st millisecond, not anywhere before that. So the total waiting time is 51 milliseconds for P5. Number of milliseconds it executed before. We see that P5 never executed before, so it is 0. And then the arrival time of P5 was 9 milliseconds. So 51 minus 0 minus 9 is 42 milliseconds. So we have got the waiting times for this set of 5 processes. Now calculation of the average waiting time is very easy. So the average waiting time is 38 plus 0 plus 37 plus 28 plus 42 divided by the number of processes, which is 5. So that gives us 145 divided by 5, which is 29 milliseconds. So this is the answer to our question. So let's see if we have this 29 milliseconds in our options. So if we see our question, we see that option A is 29 milliseconds. So the answer to the question is option A, which is 29 milliseconds that we have just calculated. So that is how you calculate the average waiting time for a preemptive priority scheduling algorithm. And always keep in mind that whenever you are solving this kind of problems, the most important thing is to form the Gantt chart. So quickly form the Gantt chart correctly, and after that it becomes very easy to solve the problem. So I hope this was clear to you. Thank you for watching and see you in the next one.